Hello students, this is Karthik, your maths tutor, heartily welcoming you all to Vista's Learning. What is Vista's Learning? Vista's Learning is an online education platform where we strive to deliver quality education for all. So students, in our previous session we had finished the second chapter of class 11 mathematics. So moving on to the next chapter is the third chapter. It is called as Trigonometric Functions. So before we start with trigonometric functions, so just let us have a look what we had studied in our class 10. Okay, so just a recap or introduction to trigonometry. So in our previous class, that is in class 10, okay, you had studied about the different ratios of trigonometry as well as their applications in heights and distances. All right, so in this class, just have a quick recap of whatever we had studied in class 10 and moving on further. Okay, so basically starting with the word trigonometry here. All right, so trigonometry. Okay, so what does tri stands for here, students? Obviously you know that is 3. Gono is nothing but sides and metry is nothing but measurement. Okay, so gono and metry, okay, these are derived from Greek language. So what do they represent? They represent sides and measurement. Okay, so 3-sided measurement is called as what? Trigonometry. And also, so sides we are mentioned here, right? So when the sides come, obviously there will be angles. So 3-sided measurement means what? A triangle, okay, which has a height h and the base b and the hypotenuse, we know that. So Pythagoras theorem, maybe you have studied in your earlier classes. So what does Pythagoras theorem state? The square of hypotenuse, which is the largest side in a triangle, is equal to the sum of squares of other two sides. So this is what a Pythagoras theorem. Now there are 3 sides here, right? See, 3 sides. Let us name them A, B and C. What is this side called as? This side, okay, so for example, if we take an angle here called as theta, what is this theta? An angle. So when is an angle formed? Angle is formed when 2 straight lines meet at a point. Okay, so there is an angle forming here. So if theta is given here, this side will become the adjacent side. The side opposite, so see, theta is here, right? What is opposite of theta? This side AB. This is called as an opposite side. And this side, the longest side of a right angle triangle. So right angle is here, students. Okay, the longest side of a right angle triangle, this is called as what? Hypotenuse. So let us write Pythagoras theorem for this. So that is nothing but AC square equals AB square plus BC square. What is this, students? A Pythagoras theorem. So in your previous classes, you have studied different ratios of trigonometry, right? So what are those ratios? Sine theta, correct, cos, tan, cot, secant and cosecant. Why only 6 ratios, students? Why not 7, 8 or 9 or 10 ratios? Why there are not 10 ratios? So the answer for this is given by another chapter. Okay, you will be studying in further classes. That is nothing but permutations and combinations. All right. So see, there are 3 sides, right? Side number 1, side number 2 and side number 3. And what are these called as? These are called as ratios, right? And ratios will be having what? One numerator and one denominator. Correct. 3 sides are there. 2 blanks are given here, ratios. Now you have to fill these 3 sides in those 2 blanks. So how do we do that? 3p2 means out of 3 sides of a right angle triangle, 1, 2 and 3, we are going to fill any 2 sides here and here, any 2 sides. So that is how do we write that mathematically? 3p2, arrangement. So what is 3p2, students? 3 into 2. So how is that? Okay, you will be studying in further classes. I am just explaining. So 3 2s is 6. So that is the reason we have 6 ratios here. Sine, cos, tan, cot, secant and cosecant. So what are these ratios, students? What is sine theta? What is cos theta? Okay, sometimes what happens, some students get confused in the ratios. So to clear those confusions in the ratios, okay, I'll be teaching you something called as mnemonics. Okay, so what is the meaning of mnemonics? I'll write down here. Have a look. It is called as mnemonics. So what are mnemonics? First of all, I'll tell you that. So mnemonics are the shortcuts, okay, which are used to remember the complex things without any mistakes. Okay, this is called as mnemonics. So what are the mnemonics? What is the mnemonic to remember all these ratios without any mistake? So that is what I'm going to tell you. So on the board, so the words are very simple. Some people have curly black hair and tight pulled back. So students, what you have to do is you have to remember these three lines. What are these three lines? Some people have, very simple, curly black hair and tight pulled back. So if you remember these three sentences, okay, you can write all these ratios without any mistake, and it is very simple. So these three lines are very general and simple. You can just memorize them. I'll tell you how. So now students, we'll change the color here. So the very first, okay, observe only the first letter of the word. What is the very first letter there? Yes, which means what? Sin theta. S stands for sin theta. Okay, what is the next word? First letter. Next word is people. The first letter is P. Opposite side, O, P, P. Opposite, by. Have. Again, the very first letter is H. So that is nothing but hypotenuse. Sin theta is equal to opposite by hypotenuse in one line. Done. Next, C, cos theta. B, that is nothing but base of a triangle. So what is the base of a triangle called as? Adjacent side. Okay, base or adjacent, both are same. You can use either base or adjacent. So let us use adjacent only. Okay, if you use base also, that is fine, students, not a problem. So B for base and H for hypotenuse. Next, T, tan theta, which is equal to P, opposite side divided by B, adjacent side. See, very simple, right? Some people have curly black hair and tight pulled back. Sin theta, cos theta, tan theta we derive from these three sentences. Very simple sentence, students. Just memorize this. Okay, so you will be getting these three ratios from these three sentences. Now going on to the next three ratios, which is cot, secant and cosecant. What we'll be doing there is inverse. So this is opposite by hypotenuse, right? Make it ulta, inverse, students. So if you make that ulta, what will you be getting? Hypotenuse by opposite. Do ulta for this as well. What you will be getting? Adjacent by opposite. Make ulta for this as well. You will be getting hypotenuse by adjacent. Correct? Just inverse all those. Whatever you got from these three sentences, inverse that. Now what is hypotenuse by opposite? This is cosecant theta. Hypotenuse by adjacent, secant theta. And adjacent by opposite, cot theta. Understand? So what is the inverse of tan? Cot. What is the inverse of sine? Cosecant. What is the inverse of cos? Secant. Are you getting this? So just remember these three lines, mnemonics for trigonometric ratios. Once you remember these three lines, you can derive sine, cos and tan. Inverse all the three, you will be getting the rest three of them. Cosecant, cot and secant. So as I said, if you remember this, out of three sides, we are going to fill any two sides in this ratio. Is any other side possible here? So opposite by adjacent, that is done. Opposite by hypotenuse, done. Hypotenuse by opposite, done. Hypotenuse by adjacent, done. So try to fill these three sides in these two blanks. So you'll be getting 6 ratios. And what are those 6 ratios called as? Sine, cos, tan, secant, cosecant and cot. So this is what we have studied in our class 10th. So this is just a quick recap of it. Apart from this, what else we have studied in class 10, students? The table, trigonometric table, right? Ratios, sine 0, 0, sine 0 degrees is 0, sine 30 degrees is 1 by 2. So that table is also very important. Apart from that, we have also seen the trigonometric identities, which are sine square theta plus cos square theta is equal to 1, 1 plus tan square theta is equal to secant square theta, and 1 plus cot square theta is equal to cosecant square theta. You all know these things. You have already studied all these things, right? So this is our quick recap. Okay. So this is very important. What are we going to see in this? So that was trigonometric ratio, students. Now see what is the heading here? Trigonometric functions. Okay. So in this class 11th, what we are going to do is, we have already known the trigonometric ratios, right? We are going to generalize them and study them as a function and also the properties of this trigonometric ratios. So that is what we are going to do in this session or in class 11. Understood? Moving on to the next one. So apart from this, now we'll study about angles. Okay. So the next one are nothing but angles. So when is an angle formed? So previously I only told you, right? When two lines meet at one point, an angle is formed. So for example, like this. So see, this is one line. Okay. This is another line. Both the lines are meeting at this point. What is forming here, students? Theta is forming here, which is nothing but an angle. Got it? So theta is an angle. Now, the important point about this angle is, students, you have to measure the angle always in ACW. What is this ACW? Anti-clockwise direction. You have to measure the angle in anti-clockwise direction. So, you know how the clock rotates, right? The clock rotates like this. Okay. If it rotates like this, then it is anti-clockwise direction. So, what is the angle measurement here, students? Angle measurement is, okay. So, in this way, see this? Anti-clockwise direction, like this. So when you measure the angle in anti-clockwise direction, that angle is considered to be as positive angle or positive theta. If suppose the ray is like this and you are measuring it in clockwise direction, see this is clockwise, right? Here we have what? 3, 6, 9 and 12, correct? So 3 to 6, 6 to 9, 9 to 12. If you are measuring in the clockwise direction, it is considered to be as a negative angle. Okay, remember this point. Angle must and should always be calculated in anti-clockwise direction. Okay, moving on to the next one. The same thing I have written here. So this is the initial side. So the horizontal line, this is called as the initial side. And this line has shifted up in anti-clockwise direction, correct? From 3 to 12 it is going. 3, 12, 9 and 6. It is going in anti-clockwise direction. So this is what? Initial side. This is called as terminal side. Here the angle is measured what? This is positive angle. So you do it in the clockwise direction as given here. See clockwise direction. This is 3, 6, 9, 12. See, it's moving like this. See the direction, arrow mark. So this is considered to be as what? A negative angle. So again, the same initial side, and this is called as a terminal side. So this is all about angles. Moving on to the next. Okay. So angles are measured in what unit, students? Unit of angles. Yes, that is degrees. So that is what we have learned in school. So moving on to the next slide now. Different system of measurement of angles. So we know only degrees, right? Now let us consider length. Okay, so this is length AB. So this must be probably how much, what would be the length of this? Around some 20 centimeters. Okay, what is the length from this point until this point? Okay, you can express it in centimeters, millimeters as well, but we can also express the length in meters, right? So what are the different units in which the length can be measured? Okay, let us start with mm. Millimeter, centimeter, meter, kilometers. What are these all things? These are the units in which we can measure the length of a line. Similarly, students, how the line can be, or the length can be measured in different units. In the very similar manner, angles can also be measured in different units. So what are those different units? The very first system of measurement is called as sexagesimal system of measurement. Okay. The next system of measurement is called as centesimal system of measurement. And the third one is called as circular or radian system of measurement. In sexagesimal system of measurement, we are measuring the angles in terms of degrees. So this is what is taught in our schools and this is what you have known. Going on to the next one, centesimal system of measurement. Here we are measuring the angles in terms of grades. Okay, and the last one, circular system of measurement. Here we are measuring the angles in terms of radians. What are all these three? These are also the system of measurements, means like how millimeter, centimeter, meter and kilometer, right? Similarly, degrees, grades and radians. So these are the three systems in which we can measure the angles. Okay, so now students, I'll tell you this. Let us take a line like this and like this. Let this be O, let this be X, let this be Y. And OY, here we'll write OY is perpendicular to OX. OY is perpendicular to OX. Then what is the angle between Y and X? This angle is what? 90 degrees. Which is also called as what, students? Right angle. Am I right? It is called as what? A right angle. Now one right angle equals, so let us take one right angle. Right angle, we'll take it as a reference now. Right angle. So one right angle equals how many degrees? 90 degrees, 90. One right angle equals how many grades? 100 grades. So 100 to the power of G. So that is nothing but 100 grades. And one right angle equals how many radians? One right angle equals pi by 2 radians. So right angle, you know what is right angle, right? When OY is perpendicular to OX, the angle between Y and X is 90 degrees. So one right angle equals 90 degrees, one right angle equals 100 grades, as well as one right angle equals pi by 2 radians. So the same angle we are measuring it in different units. That is nothing but degrees, grades and radians. Alright, moving on to the next one. Relationship between degrees, grades and radians. So what is the relationship between them? So the relationship is given like this. D by 90, one right angle is equal to 90 degrees. So D by 90. G by 100, because one right angle is equal to 100 grades. So G by 100. And 2 R by pi radians. This is grades. So this is the relationship between degrees, grades and radians. So for example, now if you have degrees is given as 90 degrees. Okay, now you got an answer, let us assume, okay, by calculating something, you got degrees is equal to 90 degrees. This 90 degrees is equal to how many grades? How to get that? So take this part only. What is that? D by 90 is equal to G by 100. And what is D, students? D we just now got, right? 90 degrees. So 90 by 90 is equal to G by 100. 90 and 90 will get cancelled, cross multiply. Therefore, G will be equal to 100. So which means 190 degrees is equal to 100 grades. Similarly for this, so again you are given degrees is equal to 90 degrees. How many radians? Calculate the angle in terms of radians. Then what you have to do? Consider this and this. Understood? So here I'll write, so D by 90 is equal to, what is here, students? 2R by pi, correct? 2R by pi. And what is D, students? 90, right? 90 by 90 is equal to 2R by pi. Cross multiply this pi up, this 2 down. So R will be equal to how much? Pi by 2 radians. Understanding? So radians, pi by 2 radians is equal to 90 degrees. 100 grades is equal to 90 degrees, and 90 degrees is nothing but a right angle. So this is the relationship between. So if you are given this and you are told to calculate the grades and radians, you know what to do. Okay, take these both or these both. Okay, simplify them, as simple as that, and you will be getting the answer, your desired answer. Okay, moving on to the next one. So radian measure is equal to, so how do we measure radian again? So one more point to be noted here. Pi radians is equal to 180 degrees. So just remember this. How? Pi by 2 radians is equal to 90 degrees, right? Pi by 2 radians is equal to 90 degrees. Then pi radians will be equal to 180 degrees. So this is the point to be remembered. Okay. So radian measure, pi by 180 into degree measures. Okay. So radian, if you want to convert it into degrees, multiply that degree into pi by 180 and the vice versa, 180 by pi into radian. Understood? So we'll have a very small example based upon the different systems of measurement of angles. The example goes on like this. So this is one of the most important questions, students. Okay, this question you might not get in boards, but mark this question down. This question is asked in most of the competitive examinations, okay, including IIT mains. So we'll just try to solve this question. What would be the angle between hour and minute hand of a clock when the time is 7:20 p.m. So you have to calculate the angle in terms of grades, radians and degrees. So 7:20 p.m. means, so let us draw a circle. Okay, a clock, 12, 6, 3, 9. Okay, so here we'll write 8, 7, 5, 4, 2, 1, 11, 10. This is our clock. Now we'll try to draw that 7:20 p.m. So this is the center of the clock. 7:20 p.m. right? Let us first draw 7 o'clock. So the small hand is at 7 and the big hand is at 12. Right, students? Exactly at 7 o'clock, what is happening? The small hand is pointing 7 exactly and the big hand is pointing 12. Now what happened? What is the given time here? 7:20 p.m. is given. So 20 minutes past 7. What is happening to this big hand now? The minute hand of a clock, what is happening? It is traveling from 12 to 4, means the big hand is here like this at 4, 7:20. Now tell me one thing, students. When this minute hand is traveling from 12 to 4, will this hour hand be exactly at 7 only, or it will move forward? Yes, that is right. It will move forward, right? As the minute hand is traveling further, our hand also will be keeping moving forward. So let us take this a little bit forward. Okay, so this will become something like this. Not exactly at 7, little bit forward than 7. Now what is our goal here? We have to calculate this angle, theta. This angle we have to calculate and express it in terms of grades, radians and degrees. Understand? So how do we do this? How do we calculate this angle? So students, in clocks, always remember, so 12 is the main thing. I'll tell you why. Because this is the number, or this is the hour which decides AM or PM. So afternoon, it is 12 PM. 1 minute before that it is what? 11:59 AM. Correct. 12 it will become what, students? PM. 11:59 PM, midnight. Exactly at 12 what will happen again? 12 AM it will happen. Correct. So 12 is taken as a reference here. Okay. So reference means, let us draw this line. Okay, this is 0 degrees. This is 0 degrees. This is 180 degrees. Okay. So now what we have to do, see this, students. This angle we have to calculate for the small hand, and also we have to calculate this angle, minute hand. So blue minus green, you will be getting what? You will be getting the angle between the hour hand and the minute hand. Understand? Okay. Now there is a question. For the hour hand, okay, the small hand, for the hour hand to complete 360 degrees, how much time is required? 360 degrees. For an hour hand to complete, how much time is required? 12 hours is equal to 360 degrees, correct? Midnight 12 o'clock, here it is. Afternoon 12 o'clock, one full circle the hour hand has, means the hour hand requires 12 hours to complete 360 degrees. Similarly, minute hand will take how many time or how much time to complete 360 degrees? 60 minutes is equal to 360 degrees. Correct? Are you understanding this point? If not, okay, take out your watch, pull that button outside which is given here and start rotating it. So you will observe the minute hand will take 60 minutes to complete 360 degrees and the hour hand will take 12 hours to complete 360 degrees. So from here, why did we write this? Just to calculate the angles. So this is 12 ones are, 12 30s are, correct? 0 0 cancel, 6 ones are 6 6 are. So from here we can write 1 hour is equal to 30 degrees and 1 minute is equal to 6 degrees. Understood? So now how many hours have been passed, students? 7 hours have been passed, correct? 7 hours means exactly here. So that is 7 hours. From here until this black line, it is how many hours? 7 hours. But is this small hand at exactly pointing at 7? See, if it is exactly pointing at 7, then it is 7 hours. This small hand has moved a little bit forward, right? So how to calculate how many hours the small hand has traveled? So just convert the minutes into hours. So 20 divided by 60, 0 0 cancel, 2 ones are, 2 threes are. So therefore the hour hand has traveled 7 1 by 3 hours. It has moved a little bit forward, right? That is why we are getting what? 7 1 by 3 hours. So this is the hour hand movement. And how much the minute hand has moved, students? From 12, if you see, exactly at 4 it is. Exactly at 4 means 20 minutes. So the minute hand has moved 20 minutes. So this is only the hour hand. Okay. It is not exactly at 7. Understand? When it is at 7:20 p.m., the hour hand has moved a little bit forward, right? How much forward it has moved? 1 by 3 hours forward it has moved. Understand? So 7 1 by 3 hours, it's a mixed fraction. So 7 3s are 21 plus 1, 22 by 3 hours. And this is 20 minutes as it is. But what do we know? We know this, right, students? 12 hours is equal to 360 degrees. Then 22 by 3 hours is equal to how many degrees? So cross multiply. So let us put question mark here. Cross multiply, and if you solve it, you will be getting 220 degrees. So you can check this out. Okay, just cross multiply and find out what is the question mark. You will be getting 220 degrees. So similarly, 20 minutes, 1 minute is equal to how much you see here? 1 minute is equal to 6 degrees, right? So 20 minutes will be equal to 120 degrees. So this is 120 degrees. So now you have a look at the diagram, students. See this. From this blue line until this red line, what is the angle? 220 degrees. Again, from this reference blue line until the minute hand, what is this angle? This angle is 120 degrees. So if we subtract these both, will we be getting this angle between hour hand and minute hand? Correct? So 220 minus 120 is equal to how much? 100 degrees. So 100 degrees is the angle between hour hand and the minute hand when the time is 7:20 p.m. Okay, I think you have understood this. Any point if you're not getting in this calculation, okay, please do let us know by commenting in the comment section. Now, we have got the degrees here, right? 100 degrees we have got. They are asking us to express this in terms of grades, radians. Degrees is done already. So how to express this in grades and radians? So that is what we have seen previously, right? So if degree is given as 90 degrees, substitute that angle here, cross multiply and simplify, you will be getting the angle in terms of grades as well as in radians as same. Okay. So this is all about an example, okay, which is related to measurement of angles in different systems. What are the three different systems? Hexagesimal, centesimal, circular or radian system. Okay, in our next slide now, what we'll be seeing is same thing but with a shortcut. So this is the shortcut, students. So what I have done here, the working, this is absolutely right. Okay, you can pause the video and make a note of it. But this is a little bit lengthy, right? But the logic is perfect. There is a logic for this problem. So with the help of logic, we are arriving at the answer that is 100 degrees. Now, what we'll be seeing here is shortcut method, which means 11 by 2m is equal to 30h plus or minus theta. And what is the time given to us? The time given to us is 7:20 p.m. Students, in the previous slide, if you see how much working has been done here. So I think we have occupied the entire board, okay, to make you explain how we got the answer as 100 degrees. So in this shortcut, what will be happening? Okay, within some 15 to 20 seconds, we'll be reaching the final answer. That is why it is called a shortcut. So what you have to do here is 11 by 2 into, what is this m students? Minutes. How much is that? 20. Just directly substitute. No need of conversion, no nothing students. Direct substitution. 30 as it is into, what is h? 7. Plus or minus theta, will write it as it is. So 2 ones are, 2 tens are, 11 into 10 is 110. 30 into 7 is 210. So now plus or minus theta. So this plus or minus theta will depend upon LHS and RHS. Here what is happening? LHS is lesser than RHS. Then what you have to do is, you have to take theta as negative symbol. Just remember this. Vice versa, if RHS is greater than LHS, then what you have to do? You have to take theta is equal to positive. Now which case we have? We have this case. So take theta is equal to negative minus theta. Why? Why negative only? Why not positive? Because theta is what we have to find out, students. What is theta? An angle. An angle between two hands of a clock. Hands of the clock are meeting at a point at the center. Correct? So now send the theta that side, what it will happen? It will become positive. Theta equals, bring 110 this side. 210 minus 110, which is equal to 100 degrees. How quickly we got the answer? Correct? So remember this formula, special formula. This is a shortcut to find out the angle between two hands of a clock. Especially for that. Okay. The calculation becomes very simple, but you have to remember this point. Always theta must be positive. Theta cannot be negative. Angle between two hands of a clock. Now let me explain you the last thing, which is called as radian. What is a radian? How is a radian formed? Okay. Very simple, students. So we'll change the color first. Let us take a circle with the center. We'll call it as O. Okay. So now this will be what, students? This is center, right? So this will become radius R. Let us assume that R is equal to 5 centimeters. Okay. We are talking about radians, which is nothing but angle. And when is angle formed? When two lines meet at a point. Now there is only one line, right? Let us take another line. From the center only, let us take that line here. How much is this line measuring? 5 centimeters, which is equal to R again. Correct? See this? This is also 5 centimeters. This is also 5 centimeters. Now, if this arc length starting from this point until this point, if this arc length is also 5 centimeters, understanding, if that arc length between those both points is also 5 centimeter, then the angle formed at the center of the circle is 1 radian. This is how the radian is formed. Understanding how the radian is formed? Radian is nothing but what? When these both lines in a circle, when two lines meet at a point whose lengths are equal lengths, 5 centimeter, 5 centimeter, and the arc length is also equal, 5 centimeters only, then the angle formed at the center of the circle is said to be how many radians? Is said to be 1 radians. So this is the definition of radian. I think you have understood this. Okay. So in today's class we saw what all things, students? Introduction to trigonometry, the mnemonics. So that is what? Some people have curly black hair and tight pulled back. You remember this, you will be getting 6 ratios without any mistakes. After that we saw what? Different types of measurement of angles, like how length is measured in different units. Angles also are measured in different units, degrees, grades and radians. Next what we saw? The relationship between degrees, grades and radians, as well as one example problem. At last we saw a shortcut with the help of and also the definition of radians. Understood? So that is all for this session. I'll be meeting you in the next session with the next topic of trigonometric functions. Until then, please do take care, sanitize your hands and wear masks. Subscribe to Vista's Learning. Thank you, students.